I'll start recording. All right, cool. So we have 2 weeks left. We've got this week and next, and then final exams, and that's it. We're done for 2019-20. And I think as a course, we're in good shape here. We've got just enough time to go over the things that I think we should go over. And I think most people in this course are in good shape as far as what they've learned about Java and object-oriented programming and stuff. So any concerns, right, definitely come and talk to me. But I think we're in a good place right now. So my plan for this week is to talk mainly about threading, although I want to talk a little more about client-side network connections. I'm just going to run through some code really quickly, and then we'll start talking more about threading. I posted a video Saturday that covers the basics, but there's a lot more to the story than just that. So before I jump into that, good time to ask any questions anybody has. All right. Let's play with Eclipse today. Because mostly I've been working from the command line, but since you're doing GUIs, you're probably working from Eclipse. So let's do the stuff we do from this environment for now. And it'll give us a different view of managing multiple processes and things like that. So I don't know what I have in SOC 1. Let's see what we got. Alright, so I've got a main socket test. I am creating a server socket on port 9999. I'm accepting a connection, and then I'm reading input and printing it out here. So if I run this, right, my console output is down here at the bottom. So let me go ahead and telnet to port 9999, and whatever I type in here gets sent out over here. Okay, so this is where we left things last week, basically creating a server connection, a server socket that'll accept connections and read input from it. So let's flip to the other side. Let's make the equivalent of telnet. Let's make something that can connect to a socket. Okay, so I've suggested not to do this, but I'm going to do it. I'm going to make a new project, and I'm going to leave it open while my socket project is open. Okay, this is because I want to run two programs at once. Now for NetDot, it's just one program, and you're going to have a radio button to choose whether you're a client or a server, but I'm not going to get that fancy today. I'm just going to go ahead and make two programs. So I'll call this main client, and here's all we have to do to make a client-side socket. So I'll make it a socket sock. And to construct a socket, we specify two parameters in the constructor. The first is the IP address in quotes, or the host name in quotes, of the machine we want to connect to, followed by the integer port number. And we need to import socket, of course. And then we need to put all of this socket stuff inside a try-catch block. So we'll construct our new socket. It should be complaining about a try-catch block. What doesn't it like? Okay, we'll figure that out. Oh, we need to be in a main method. I did not have it make me a public static void main. Oh well. Alright, so we'll make a socket, and remember what we can do, we can create a print writer to write to that. And we can create a scanner to read from it if we want. And then we can do something like pw.println. Alright, so I'm just going to do a really simple client code here. Instead of reading from standard in and so on, I'm just going to send 3 messages out to the server side socket. We should be tactical in our use of try-catch blocks, right? Try-catch block, try-catch block, try-catch block. I'm going to be lazy, and I'm going to put this whole thing inside a try-catch block. So let me fix my imports first. And then let's go ahead and declare these. Very weird, it's not complaining about try-catch blocks until I put in that closing bracket. So let's surround with try-catch. Alright, so this is not code you should ever write. This is really sloppy. Because I'm not doing anything if we get an exception. I'll do something if we get an exception. There we go. Now we're handling our exceptions. Alright, so if I run this code, right, this should try to create a connection to port 9999 on the local host. If I do this, I'll immediately get an error saying connection refused because there's nothing listening on that port. So what I can do is I can come back here to my server code, okay, and I can run that, and it tells me this is main socket test, okay, and that's listening for a connection. And then I can come over here to my main client and run that, and I see, you know, stuff here being printed out. And it says terminated main socket connection. Okay, so if I was doing this from the command line, right, it would look something like this. What is this called? I think it's SOC1. So I'm in the bin areas for these two things. I can say Java main socket test, and then over here I can say Java main client, and when I run that, I get my output here from the main socket test. And I got empty lines here because for some reason I put new lines at the end of my print lines, which I didn't need to do. So you know, my recommendation is if you have access to a terminal shell, right, run these in separate terminal shells, and then it's really clear which output is coming from what. And just to, yeah, I won't put a print writer there. But if you're doing this from Eclipse, right, you can do some things to clarify this. For example, over here, there's a window which says Open Console, okay, and you can say New Console View. And I have two console windows here now, right? I have this one which was terminated from main socket test, and I have this one which says terminated main client. Okay, so I can come over here to main socket test, and I can click on my main socket test and say run, and I can come over here and click on main client and say run. Okay, but this window has switched to being main socket test, right, and my main client switched over here. So if you're really careful and you pay attention, right, and you can pop these things out into separate windows, which can you know, sometimes help. You can do this debugging inside Eclipse. But to me, it's a little weird because, for example, I just started a socket. Both of my windows are now showing me my main socket test. You can see my run marker is red. And if I come over here, I can say one of these will let me switch my console view. I've only got one console available right now. Alright, well anyway, you can do it, but it's easier if you drop into a DOS shell or a Linux terminal and run your binaries from there. And this is, let me close these out. This is also nice because, for example, if I come in here and I want to make a change, right? All I have to do is save my code. I just did a Control-S to save it, and I can go ahead and rerun this. My socket's already running. Show console. Okay, let's stop that. So I can come in here and I can rerun my server, and I can come over here and rerun my client, and those changes are immediately made available, right? If I want to put some more code in here, I can Control-S to save it, and then come back here, rerun my server, come over here, rerun my client, and there's my new changes. So it's a very rapid development cycle, right, to use Eclipse in combination with the command prompt. I think it's more efficient than just living inside Eclipse. But figure out what works for you and stick with that, okay? All right, so let me talk about threading. So we'll make a thread test project. And we'll make a main method, and I'll go ahead and do a public static void main. And if you've seen the video, you've seen this before, right? So we'll make a thread of type myThread, and we'll create a new class called myThread. I'm going to say my class extends thread. Okay. So let's make a constructor. So the constructor is going to just be used to store an ID associated with this thread. So public my thread integer I. And so in the thread I'll have an integer ID. And in the constructor I will say, you know, here's an integer, let's save that as our ID. And then I'm going to write this, this run method. And I'm going to print out the ID colon followed by this integer I. And I'm going to do this all on one line side by side. And then I'll say goodbye. Alright, so I'm going to have a couple of threads. I'll make 3 threads. And I'm going to pass an ID to each of these. And first thing I'm going to do is I'm going to call the run method. On each of these. Alright, so there's no threading involved yet. I've said that this extends a thread, but I have a method called run, and I'm just calling the run method on each of these 3 objects, which is an object of type myThread. And if I run this, I gotta make my console window appear again, right? I get I get an unresizable window. Okay, so I get all this output, right? Not exciting. So the trick with threading is, let's call the start method. And remember, start does 2 things. When I call start, it first says let's create a new thread, and then it says let's call the run method in that thread. So right here we create a new thread, and then that thread's run method starts executing. And then we create a new thread and we start that thread's run method, and then we start a 3rd thread, call that thread's run method. And let me just throw a message in here. And I'll just say main program is exiting. So now when I run this, something very different happens. Right? So thread 1 started executing and it printed out, I just love Eclipse. It printed out sequential numbers. And it actually got all the way up to 99 and then said goodbye. And then main program exited. And then thread 2 started, and then thread 3 started. And they both printed 0, and they both printed 1. And then thread 2 printed 2, 3, and then thread 3 printed 2. And you can see they're running in parallel, right? Sort of taking their own shots at the CPU. And thread 3 actually exits first, all the way out here. right? After which thread 2 finishes up with values 80 through 99 and then says goodbye. So these 3 instances of my thread, each of those instances run method was running more or less simultaneously. And if I run this again, right, I get something very different. In this case, the main program exited right away. Thread 2 started first, and then thread 1, and those 2 shared the CPU for a while, and then thread 3 started right here. Alright, so this is multi-threaded programming. And it's a really fun aspect of programming, and it's pretty straightforward to do in Java. It's really just a matter of making a class that extends thread, putting a run method in there, and then instead of calling run, calling start. Okay, that's all it takes to start a separate process executing. Make it a class that extends thread, call the start method, but the code that you want to have executed should be in a method called run. Okay, that's really simple, but if you don't know that, it's really hard to figure out what the heck is going on when you look at code, because there's a run here, and we never call run, and we call start, and there's no start over here, and so on. Okay, so once you understand what that's doing, it's not that complex. But if you just go to Stack Overflow, you're going to find all kinds of things talking about runs and mutexes and all this kind of stuff, and it's not supposed to be that complex. Okay, to just get something running in a parallel thread, put it in a class that extends thread, write a run method, call the start method, and you've got it cooking. All right, and that's really all we need to do thread-wise for PA5. Okay, we don't need to do anything fancier than that. So what are you going to do in PA5? You're going to define a class, which I've been calling NetThread. And that's going to extend a thread. Can we focus? Hey, not bad. Okay, that's going to be a class that extends a thread, and you can do whatever you want in there, but ultimately somewhere inside here you need a public void run. And then in your other class, right, your net dot, probably in your net dot, you could do it in your panel, you could do it in your board, whatever your class structure is. But really, somewhere in the very beginning, you're going to do something like, NetThread nt equals new NetThread, and you're going to do an nt.start. Alright, and that's all you have to do with the threading. You don't have to worry about it anymore from here. Okay, this thing is off and it's running, and whatever is in here is now executing in parallel with your dots game. Okay, that's really all there is to it. Okay, so the question is, what do we do with this machinery, with this mechanism for threading? And it's a little bit of a design question, right? Which means it's largely up to you. But basically, 2 things to keep in mind. One, the networking part, right? You are going to be running your code as either a client or a server. Okay. The main difference being, if you're a client, you want to create a socket connected to a particular port. If you're a server, you want to create a server socket connected to listening on a particular port. Okay, but let's take a look at our actual code. Oh, I closed out my windows, man. right? So on the server side, we make this server socket, and we say accept a connection. But once we've got this connection, what we have is a socket, right? And we go ahead and we use that socket, S in this case, to create a scanner. We could create a print writer and so on and so forth. On the client side, we say I would like a socket connected to localhost port 9999, and once we come back from that call successfully, this thing, sock, is a socket that we can use to construct a print writer and a scanner. So at this point we have a socket, at this point we have a socket, and those two sockets are connected to each other. So whether you're a client or a server, the only difference is what you do to get to this point. Okay, on the server side you create a server socket and you say accept. On the client side, you construct a socket with an IP address and a port number, and you get back a socket. And from that point on, client server makes no difference. But the initiation of the connection is different. So what you might want to do when you construct your NetThread is pass an argument, which says, am I constructing a server or a client side? And in your constructor, right, take the argument and either create a server socket or create a socket. Alright, so one, create server socket or socket. If you're a server socket, you want to do an accept. If you're a socket, you're just creating a socket, constructing it. And then two, send my name. 3, get the other player's name. Okay, and after you get this socket, you know, get print writer and scanner as usual. Okay, so make your connection, get the print writer and the scanner, send your name to the other player, read the other player's name, and you're all set to go. So would threads be set to start when the radio buttons for server or client are clicked? Yeah, so probably the best place to do this is when the person hits the start button or the connect button. That's when you go ahead and you construct your NetThread. Because until then, you don't know if they're going to be the client or the server, right? They might flip back and forth between the radio buttons. So when they hit the start button or the connect button, whatever else you're doing, go ahead and call the constructor for your NetThread. Tell it whether it's a server or a client. It will create the I/O devices. It will transfer names with the other player. And then you're ready to do your communication. Okay. And so at that point, call your start method. Okay. That starts the run method running in a separate thread. And the main thing you can do in here is while SC has next line. Go ahead and read that. And then process what you read. And if you use the suggestion that I put in the assignment, what you're generally going to read is C followed by some number followed by some number. Go ahead and parse that out. This is going to be an X coordinate, this is going to be a Y coordinate. And so, you know, whatever class your code is in for handling a mouse click, call that. Okay, for example, if you have a handle click method in your panel object, right, panel handle click X comma Y, and just hang out in this loop forever. Okay, but one thing that's useful is passing this quit message. So if it's like a queue that you received, you know, you can print a message saying the other side is exited, click here to finish, or you can just do a system.exit right there to kick out or whatever. But that tells you that the player on the other side has left. All right, and so this is handling receiving click messages from the other player, and then your code treating them as if, the person had borrowed your mouse and clicked, right? So the other piece, the last piece of this is when you click on your mouse, you need to send the XY information of that click to the other player, okay? Well, you've got a print writer that you constructed inside this NetThread, right? So I could say, NetThread.printWriter.println and send a message. I really hope all these dings aren't people joining at 32 minutes into the class, because they're missing all the good stuff. But anyway, so you can do this, right? Even though your run method is sitting in this infinite loop trying to read from the scanner, right? Your net.class class, or whatever class this is, has access to the NetThread object, right? NT. And NT has a print writer, and if that's accessible outside of the class, you could just say nt.printWriter.println, give it some stuff, and it will go out through that socket to the other player. Okay, this is like where objects and all of this stuff get really wonderful. Okay. If I want to be a little cleaner, I could put a method inside this NetThread class called, send coordinates, that I just pass an XY to, and it takes the XY coordinates, it makes a string that looks like C space X space Y, and then it does a pw.println with that. And I could make a method in here called, send quit message, and that would be a method that just, does a pw.println quote Q. And so that's, encapsulating, that's saying all of the network stuff is going to be handled by this NetThread class, right? But even though it's in this infinite loop reading from the socket, someone else can call methods that are in this class and execute those, because my net.dot is running in its own thread separate from the thread that's doing this infinite loop. Okay, hopefully that's making some sense. Start messing with it, and it will make more sense. But that's all there is to first level threading and using threads to do this networking. So make your NetThread class extends a thread, make a constructor that somehow figures out if you're the client or the server based on an argument, and either makes a server socket and accepts a connection, or makes a socket connected to the destination address. Port 1234 for net dots. Swap names, right? So pw.println and then name equals sc.nextLine. And just return after your constructor. Wait until the start method gets called. All right, questions about that? So we already have threads running when we're talking about swing. When we make a J-frame, we're already doing something like this. You send your coordinates with, say, the letter C followed by how do you do that? Well, make a string and hand it to print line, right? So print writer.print line this string, you know, or C plus X plus a space plus Y, right? And on the other side, they're going to use their scanner object, and they're going to say, you know, it out. All right. So are people having sound issues? Let me know if you can hear me. Interesting. Well, that's annoying. Okay. Strange. All right. So let me go back to that earlier question. Yeah, my fan just kicked into high speed. So, yeah, I'm also overloading my CPU. Yeah, because I'm building this huge mansion in Minecraft in the background, and that's probably taking up my CPU. But I found a cool mansion, and I decided to clone it and scale it up, so it's doing a lot of work. So that could be a problem, but yeah, I know, right? Got to do this stuff first. But that's gonna be a cool house, man, when it's done. All right. So when you want to send your coordinates to somebody, right? The protocol I suggested is the letter C followed by the X coordinate followed by the Y coordinate. That's going to be a string, right? So turn that into a string and pass it to print line, right? Or print, you know, quote C space plus X plus space plus Y. And on the receiving side, they're going to be using a scanner.nextLine, which reads a string, right? So strings are an easy way to transfer this information, even though we're really sending our integers. If we just write the integer into this socket, right, we have to use a lower level form of I/O. So easiest way, and definitely the easiest way in terms of debugging, just turn it into a nice human readable string. And then you can use PuTTY or telnet to also, you know, read and write things between the two sides and use that for debugging. Does that make sense? All right, cool. Other questions? So if you mess up Eclipse like I did, where my console window is kind of weird, you can go to Window, Perspective, and say Reset Perspective, and it'll bring you back to your starting look and feel. And I can close out these things, but now I have my console sitting down here at the bottom again. And you can do a lot with this to make it more palatable. You can control the console and have it, you know, do automatic wrap and things like that. So here's my main dots game, right? Which is not nearly as nice as what a lot of other people turned in. Oh, you can also open a telnet terminal in Eclipse. That's cool. How do you do that? Well, someone's telling us we can open a telnet terminal in Eclipse. So in my dots program, you know, the main program, which was written for me when I made a JFrame, looked like this. And you can see there's a run method here. Okay, and this is another way to create a thread, is to make what's called a runnable. Okay, cool. So so Anna's going to post on Discord how to open a terminal in Eclipse. So in my version of dots, right, which is just a JFrame, the main method ends down here, right? And let me put a message in here. Which says main program exiting. And when I run my dots program, I get this message immediately saying main program exiting, goodbye. My main program is done, but my program, my whole dots program, is still running, right? I can still do this stuff and play dots, right? This is a separate thread. This main program that actually starts when we say run is in a separate thread from the thing that's dealing with, you know, my dots board, for example. So when we use swing, we're already dealing with threads, but not in a way that we really have to think too much about, because mostly, you know, this is written for us, and it creates the JFrame, makes it visible, and then it just exits, really. It just kind of walks out of the way, and all the action is happening inside our JFrame. But since none of our code is running, since the only thing we had was a constructor for a JFrame, which, you know, did a few things and returned, and a main method which did this and returned, right? Normally that would be the end of our code. Our program would exit at that point. But the swing stuff happens inside threads. Okay? And that's necessary because we want to be able to be doing one thing while something else is picking up mouse clicks, or picking up a request to resize a window, and so on and so forth. And if we look at this documentation, we'll always see this warning which says swing is not thread safe. For more information, see swing's threading policy. Okay? So we're going to talk about thread safety tomorrow. There are lots of little details when you have multiple threads running that we have to worry about, that we don't have to worry about when everything's happening in one process. Okay? And so we're going to talk about mutexing and deadlock and things like that. Details, and this is the same kind of details that we dealt with in Engineering 270 when we were playing with interrupts, right? Things can happen inside your interrupt handler that can affect things outside. You can spend too much time in your interrupt handler and break things. You can get an interrupt while you're in your interrupt handler and break things. So we're gonna have all these issues to deal with when we're doing threads. All right, so let me make a couple of comments on PA4. I forgot to do this in the beginning. So PA4 is graded and back to you with feedback. And PA4 looked great. Saw lots of cool designs. Played a lot of dots games, and that was awesome. One thing to keep in mind with any of this stuff is you should do all of your painting from the paint method, okay? And you should always call super.paint in the beginning. And what I saw a few people doing was either trying to draw things from, say, the mouse handler, and so they were calling a method to get the graphics context from their panel, and then calling, you know, g.drawLine inside a mouse handler. And that looks like it works until you do something like resize the window a little, and then your lines disappear, okay? Similarly, if you're not saving your information in memory and drawing from memory each time you go into Paint, you get the same effect where it looks like the lines are where they should be, but if you resize the window a little, your lines will disappear or move around into weird locations. So really think about, I want to do my drawing inside Paint, completely inside Paint and only inside Paint. Okay, and it forces you to do things like, if I want 5 lines to appear, I have to store that fact somewhere in memory and write my Paint method to say, hey, here's 5 lines I should draw, and then do that drawing. Okay, so you may have to rethink a little bit about how the Paint method is working with respect to your data structure. But that's important, okay? Now I said you don't have to have a resizable window, meaning you don't have to, make the dots further apart if the window gets bigger and so on. But you should never write code that breaks if somebody tries to resize the window. Okay. All right. Any last questions? We will talk about thread safety and threading issues tomorrow, and we'll start getting into some of the fun aspects of dealing with multiple processes running at the same time. All right, cool. Have a good afternoon. I will see you next time.